Hi there, math fans. I'm Dr. Andy Lovelace. If you're new to my channel, I've taught at the University of Washington for many years. I have many review videos. This is not going to be one of them. This is something that came up the other day, and it ties in with some of the things I'll be teaching in my precalculus course. But the question is, can you spin your arms like this? Growing up, my dad always did that. I then did a little bit of a search and realized that other people have made videos on this, but I have a long story that goes with it. So many people can spin their hands the same way. Here's the same way going forward, the same way going backwards. And to illustrate this, and I'll finish this with some math, I'm going to give some visuals. So here we go. There's two hands. The purple is my shoulders, purple dots. The orange dots are my hands. And I've drawn a few things there. I've drawn the arrows that's going. Those are actually called tangent vectors. And if you take Calculus 3 with me, you'll know how to find those. And I drew the circle so you could see it. But that's hands going the same way. So they're both going the same way. And I made it so you can tweak how far apart the shoulders are, and you can actually do this with your hands side by side, which is what most people do. They have their hands going like this. Stop it there. Let's do it. Here we go. So I encourage you to try to do the same. They're both going forward. You can also make them both go backwards. So here's both going backwards. Going backwards. Most people can do that. This is the best dancing I do. All right. What if you wanted to go opposite? Now, if you have them side by side like this and they go opposite, they're going to run into each other. You can't do it. You've got to move them apart. And so if you move them apart, then they can go opposite directions. A lot of people can't do this. Don't feel bad if you can't do this. So I'll say a few things about it, but it is different than what you're used to. So let me show you the opposite one again. I have to move my hands apart, so let's do it. I move them apart a little bit, and let's go. So now they're moving opposite ways. One is going forward, one is going backwards. And the reason I can make that visual is because I know about circular motion. I know about sine and cosine. This is a big thing we teach in our precalculus course. The reason I can do the tangent vectors and draw the curves is because I know a little bit of calculus, and I teach calculus 3. So this has been a way I've been motivating the math, and so I'll use this as an example. Another story is the power went out in one of my lecture halls. I have 200 students in there, and the power went out briefly, and the whole system had to reboot. And so we were in kind of a dim room for about 10 minutes. I had to kill time, and I had everyone in the room try to do this. It was lovely. So it's a nice little party trick. So you can try it now. I find it's helpful if you point your fingers to each other and have one go forward and one come towards you. Just start with that. Have one come towards you, one come towards your forehead. Some people say it's easier if you first try to draw a square. So go forward and back, like you're in the middle of the square, then go down, and then repeat. So forward and back, down, come up, and try to make a square. Then once you get it, then you make a circle. And again, my dad did this for years. I was sort of mad to see that a lot of people have made this video because I feel like I own this. I thought my dad invented this. And we've been doing it for years. And it's a fun little activity if you have nothing to do or you're trying to occupy some kids. Okay, so there's that. But I thought what I would finish this with, since I am a math teacher, is I would say a few things about what I found about this. And then I'll say where this might come up in math, and then I'll try to extend it a little bit, as we always like to do in math. All right, let's make my fat head a little smaller. Let's move this up in the corner. And I have a few little things to say here. So I looked this up. This is called bimanual interference. Your hands tend to want to do the same thing when you have them both active. So examples of this are rubbing your tummy and patting your head. There's another one I found online where you put one thumb up and one finger out, and you just thumb down, finger out, finger in, thumb up, thumb down, finger out, finger in, thumb up, thumb down, finger out. And they said, you can't do this fast. Nobody can do this fast. Oh, I have more practice with this. This came up because I was talking to some of my tennis colleagues that they're having trouble like tossing a tennis ball and having a different motion with the other hand. And I was like, hey, this is the same thing. It's something you can train yourself to do. Same thing like playing the piano. You have to train yourself to do this. So there's quite a few things like this. Okay, so what I wanted to say about this was really the way I made that visual was with circular motion. This is something we do, and I think it's chapter 17 and 18 of our precalculus class. I'll be teaching this probably in week 8. So sometime in November, I'll be teaching this year. But it's just this basic idea that if you have the angle measured off of the rightmost point and you have the radius, you can give the location. All you need is the radius and the angle. And that's how we define sine and cosine beyond 90 degrees. Students learn the unit circle, but what's useful is animating rotations like this. Oftentimes we break down the angle into some starting angle and some speed we want it to go, angular speed, basically how many degrees or radians we want it to complete a second, and then this is the time. So the full formula usually has the more practical, user-friendly formula has a starting angle, and you insert these things here. And that's all I did to make that visual. Now I had to do a couple clever things, as you always have to do, but you need the principle first. So my students will do that. And because I am doing lots of things with Desmos, I'll also teach you how you can do it in a computer, and you can make the same animations I can make. Students have told me they've wanted me to do that more, so I'm going to do a little more of it this term. What I actually did is I made it rotate. I fixed the X value at whatever I want it to be. In this case, it's 1. And then I made this. And then I also did it at -1. And then I changed the angular speed. One was positive, one was negative for clockwise or counterclockwise. I took the derivatives and made the tangent vector, and that's how I drew that tangent vector. So a little bit of calculus and you can do something like this. I have many videos on circular motion. I think the applications are enormous. I made one with like the Disneyland teacups, and you can see them rotating. It's a true model. Okay, so that's kind of my goal here. So I thought, how could I end this with a more interesting question, as I always like to do? And I was thinking of like other ways you could do it, like put up your dukes. I don't know. Tell me if you could think of a clever thing. So please ask your own questions, as I like to do. So I will show you the one thought I had here was, what if I rotate opposite and at the same time rotate my arms up? I can't quite do that. What do you get? So that was the animation I made, and it loops out this shape. So that's if I kept doing it a lot. And it's funny to make him go opposite as you rotate up. I don't think I can quite do it, but this is what I got. Is this it would trace out this shape. So there you go. What's that shape? Lots of questions you can ask just by tweaking models like this. All right. Hope you found that interesting. Thanks for listening.